Hi. So, welcome to the second lecture of Comp 1531. Today we're going to be going through the rest of the week one topic. As you would have seen from the Monday lecture, we covered quite a bit on Monday, particularly in relation to a bit of a course overview and then everything to do with Git. Whereas tonight we're just focusing on lecture 1.4, which is the JavaScript lecture. If you haven't already seen the lectures from Monday, and this is true for all future lectures, they are snipped up and placed here like this. So you can go back and watch those lectures at any time. Big hello to everyone online. I understand that there are going to be people who are watching this who have discovered the anomaly in relation to UNSW timetabling, where they decided to make a mistake and not put one of our lectures on the timetable. So it's kind of been on the timetable now, but it also they didn't enroll anyone in it. It's very weird, but we do have these lectures on a Wednesday typically. Occasionally we will, run them in person now and again, and we will move them around a little bit. But again, everything's recorded, so it's all pretty fine. There's nothing particular to worry about or stress about now. Bonrick has already asked, how will we know if it's in person? That's really easy. I'll tell you many times, right? But generally speaking, it's because it's written on the timetable page. You can go and look at that anytime and just see what's happening with the lectures, right? It says it here very clearly. You'll get told many a time in advance. As long as you're reading your emails and you're actually looking at the course website, you will not miss that memo. You will have all the information that you need. So Valeranova has also asked a question, which is, isn't it weird that we have labs before our second lecture though? Let me touch on this briefly. So it's an interesting question. Why do we sometimes have labs before our second lecture? So, the answer is because ever since UNSW moved to trimesters, they've done particularly strange things with how they structure courses. There has been some pushback to ensure that there is at least a lecture before the labs, is very common now. But the shorter answer is that throughout the rest of term, we make sure that this is true from week 2 onwards, we make sure that there are only the content in your tutes and labs in a given week are based off the lectures from previous weeks. So essentially, this is the only week where you will have, lectures, if you will, that maybe lag, the content slightly. And that's just because the only other alternative was that, we just simply do not, how would you put it? We just simply don't do anything in week 1, right? We just do nothing at all. So yeah, to the people again who've made a comment about, we're not really sure what's going on with the lectures. Again, you can just go look at the actual timetable page, right? Yeah, okay. Some people haven't been looking at the timetable page is the conclusion. All the information's sitting on WebCMS3. You can just go look at it at any time. As I mentioned in the Monday lecture too, we had a one-off in-person lecture on Monday, and the rest will be pretty clearly signposted, right? So go read your emails, go check out the websites. You guys are funny. All right, we're going to get stuck into it. So today's pretty much all about JavaScript. We are going to be learning about a programming language, and we'll do a little bit of prefacing and some other stuff. So why are we talking about this today? Why are we learning about the language JavaScript? The reason is because JavaScript is an extremely valuable tool to know, and it's necessary for the project. What we're going to be talking about today is we're going to be learning about how to learn a second programming language, because for many of you here, particularly those who've come straight from 1511, this will be the second time you've learned a programming language. You probably haven't learnt many others beyond C. So there's a little bit of a new thing for you there. We will be talking about JavaScript with respect to C, because that's just kind of how some people learn, right? Some people just want to understand JavaScript based on what they already know. And then we're going to spend a lot of time on core JavaScript language features. So essentially just get into more of what the language can do. Now, a bit of a disclaimer. I kind of mentioned this, I think, at another point maybe, or I dreamt it, but because you already know C, we're going to be teaching JavaScript very quickly and mainly focusing on the differences between that. And this is again kind of the case throughout your university degree. So when you learn your first language like C, we kind of go through everything. You know, if statements, while loops, like literally everything from scratch, and take it really, really slow. Whereas once you start learning other languages, you really speed through it. And in fact, when you get to like a later point in your degree, you won't even have stuff like this. I think I've mentioned this before somewhere, where later courses, they'll just be like, it's time to learn a new language, go and teach it yourself as you go. And that's like very, very kind of common as well, and something you might experience in industry later on. So unlike C though, and this is really interesting, JavaScript has a sprawling set of capabilities. What that means is that the language itself will feel much bigger. One of them, and this is true for actually most programming languages, right? This is less about JavaScript and more about C. C, the coolest thing about C is that it's a really small programming language. You can kind of write it down on the back of a card, like a little piece of paper, right? So that's why it's so great to teach, because you can essentially teach it all in a nutshell. JavaScript, like many other languages, will feel a bit bigger, and that's an experience you're going to have as you do this, as you're going to go, damn, this language is quite large. I feel like I don't know everything, and that's totally normal. Don't stress out. So don't expect to know everything about JavaScript this term. It's not like C, where you will finish the term and be like, I get the language, I can't solve all the problems. You will finish the term and go, I feel like I still have a lot to learn about it, and that's totally okay. So don't put that kind of pressure on yourself. You know, that's what really matters. Now, what in the world is JavaScript? So JavaScript is a high-level multi-paradigm scripting language. Whoa, what is a high-level multi-paradigm scripting language? So being a high-level language means that it is further and further from hardware, right? So C is a low-level language. You're dealing with things like memory and pointers. High-level languages, you don't deal with stuff like memory and pointers. You don't need to worry about malloc and free. So it's a high-level language. It's a multi-paradigm language because it has elements of, and there are many multi-paradigm languages, but it's got kind of functional-ish elements. It's got imperative procedural elements like C. It's got some object-oriented components in, you know, maybe languages similar to Java. And it's a scripting language. And what scripting languages are essentially languages that you can kind of just like, you know, write 1 or 2 lines of code and execute them, right? Now, many of you are still quite young in your degree, so you probably don't have a lot to draw on, but languages like Python and JavaScript are scripting languages, whereas languages like, you know, C++, Java, C, they're, you know, less scripting languages. Are a bit more kind of structured in their approach. The interesting thing about JavaScript, it has a massive, Valeranova, I hope I'm saying that right, says, so no int main, basically. Like in C, if you, like in JavaScript, and we'll see this, you can just write like print hi, whereas in C you have to be like int main, you know, this, that, return this, and all that kind of stuff. The reason JavaScript's interesting is because it has an absolutely massive popularity in the web-based software engineering space. Basically, if you're building some software on the web these days, you are probably doing it in JavaScript. That's one of the many reasons why we teach this language in this course, because most software is web-based these days, and this is the popular way to deal with web-based software. And therefore, JavaScript has become the universal go-to language to build web applications, which is really, you know, as I said, pretty much the most common way that we build applications these days is for the web. You know, so very interesting. Here is a very simple sample piece of JavaScript. Now, this by itself doesn't do anything, but it kind of gives you just an early hint of the syntax. You can kind of see here that, you know, we're declaring a variable called a, it's equal to 3. We're creating a function called hello that takes in 3 different parameters, and that function returns, that's a typo, that's silly. This should be a. This function returns a here. Right? These are all very new lecture slides, so I do apologize. We will come across the odd typo throughout the term. So this is like, it should be a here. So basically a function that takes in a, b, and c, and, you know, it prints out a. I mean, it's not even really a typo because this code doesn't make any sense, right? Like, you've got a here and a in the parameters. It's not really meant to actually run. This code doesn't run. It's really just like, this is what it looks like, right? Now you see this and you're like, okay, well, that looks kind of like C, except I don't know what data type const is. And, you can see that we're passing in these parameters, but it's not really clear what types the parameters are. And then we've got this strange $ braces inside these backticks, which is a little bit weird, right? So there's a few weird aspects of this, but it kind of looks like programming, you know? So we're going to keep going deeper into that. Now, other reasons that we talk about JavaScript in the course, and why we tackle this, it actually has not a lot to do with the language itself, right? There's always people who like to complain about things, who like to complain that, you know, JavaScript isn't a good language. But why we teach it is actually because JavaScript has an incredible, rich open source library and package manager that allows you to build apps really quickly. Basically, JavaScript can help you not have to reinvent the wheel. And we're going to talk a lot more about that next week. JavaScript is high level, which means it's really quick to write code. It's super well supported in industry. It's probably like the most well supported language. So if you're the kind of person who wants, you know, a typical job in computing, it sets you up very well, core and foundational. And particularly, it's really, really common in large software engineering projects these days. So you go to a large company building a large project, there's a very strong chance you're going to interact with this language. But it's the infrastructure around it that makes it really interesting. We're going to be talking about that in future weeks. We're going to be talking about automated ways to manage style, to download packages, to do testing. Lots and lots of stuff that interests us much further beyond just the language itself. Now, we've been talking about learning another language, and we talked about the whole multi-paradigm thing. And let's just have a little bit more of a deeper look at this to kind of get a sense of, you know, where some of the differences are between a language you might have already learned, like C, and then JavaScript. So you can see C at the top of the table here and JavaScript at the bottom. Now, C is a procedural programming language, which means that, you know, you write code and it runs from top to bottom, or like, you know, it jumps around, but it goes in a linear flow pretty clearly. And it's not object-oriented. Now, most of you, again, would not have been exposed to object-oriented programming because you haven't done 2511 yet. But you'll see other languages like C++ and Python can do both procedural and object-oriented coding. Languages like Java are only object-oriented, right? That's why we call JavaScript Multi-Paradigm, because it can kind of do different things. Languages like C and C++ and Java, they have types, int, doubles, chars. Whereas languages like Python and JavaScript, they can have types, but it's not built into the language. So, you know, the language itself doesn't necessarily mean that there are types. That is a typo. Jacob has pointed out that C++ should have pointers. That is correct. Thank you. C++ and C deal with pointers, right? But Java, Python, and JavaScript don't. And then C, C++, and Java are all compiled languages, right? Which mean that you actually go and take the code and you turn it into like a machine code that you then run. There's like a separate compilation and running step. Whereas for languages like Python and JavaScript, we don't have that. They're what we call interpreted languages. And that's a big difference, which we'll kind of chat about a bit. Jed's asked a question: what's the difference between Java and JavaScript? That's a great question. A lot. They have really nothing in common. That's like asking what's the difference between JavaScript and C. They're just very different. So the summary of what we just said before: JavaScript has object-oriented, unlike C. JavaScript does not deal with types, right? As out of the box like C. JavaScript won't deal with pointers. JavaScript's higher level, and it is not compiled explicitly. Now let's actually start having a look at code, because I've been talking a bit too long. So if we have a look at code and we want to write ourselves a function that takes in two numbers and returns the smaller number, this is how we do it in C on the left-hand side, right? Int minimum, int's the return type, minimum's the function name, int A, int B. If A is greater than B, return B. If else, you know, return A. When we look at it in JavaScript, it's quite similar. There's only really two things you'll notice that are different. The first one is that instead of saying int for the return type, we actually just say function. And then you'll also notice instead of saying int A and int B, we just have A and B. So the main thing that you're noticing in this particular use case, right, you know, is that we just don't have types. It's really, really that simple. Just that simple. JavaScript doesn't have types. And this is kind of useful because it means we don't have to worry about what something is or what it can turn to. But you will also notice that as we'll touch on later, when you define functions in JavaScript, you still need that kind of function keyword there, you know. So now that we've defined these two functions, both minimum, let's actually call them, you know. And calling them looks very different. So we see here in C that to call it in C, you need to obviously create your int main, int argc, char star argv. Then you need to do a printf, and you do the %d to get the number, and the new line to get a new line, and then you call minimum between 3 and 5, right? Like that, right? And because you're using the printf, which is a function that you didn't define as part of the C library, you need to actually also include, or hash include stdio.h. Whereas in JavaScript, all we actually have to do to print out the minimum of 3 and 5 is write the statement console.log minimum 3, 5, like that. Now, that's super interesting because it's simply just saying you don't need to do anywhere near as much, you know, work to actually make something happen. And how does this actually manifest? Well, what I've got up here is I've got VLab up here, and I've actually got all the lecture code. You can find the lecture code just by like on the slides. You can just click on it and get access to it, you know. But I've got a dump of the lecture code here, and I'm going to show you how we might run something like this. So I'm just going to go into the folder that this stuff's in. Give me a sec. And you can see I've got, what file have I got here? 1.3 compared to .js. So there's my file. Now, let me just double check I'm not missing a slide. Yeah, okay, there we go. I was jumping ahead a sec. So in C, if we wanted to run that, we would have to, maybe you might use DCC or some other kind of more helpful compiler, but you would have to actually write like gcc -wall -w error -O -o or something like that. You need at least the -o. You know that second dash, the first -o should not be there. You'd have to write something like this, you know. And then once you did that first line, once you executed that line, you would create a machine code piece called runnable, and then you could run the runnable and it would run it. Whereas in JavaScript, with JavaScript here, all we actually need to do to make it work is just to write node and then this. Now you might ask the question, what is node? You know, that's a very strange word. Like it's not JavaScript or something like that. You know, it's just called node. So let's actually touch on what that is. Because it kind of feels a little bit too easy. So NodeJS is something you might have heard of before, and it has a lot to do with JavaScript. NodeJS is really just a command line interface that interprets JavaScript code and runs it, right? And that's all there is to it. You can kind of get deeper in that and get into like runtime environments and core engines, but it's quite literally a program that takes in JavaScript code, which is just text, right? Because code is just text. And it actually just compiles and runs it. It's kind of, you know, and we've written it here, it kind of follows a very similar idea to what GCC was if GCC not only compiles it, but it runs it right after. And therefore, right, because this compilation and running is in the exact same step, this is why we call JavaScript an interpreted language, right? This is, NodeJS is known, the language there might not be totally correct, but it's just when it's all part of the same step. Now, what's the difference between something like C, which has that explicit compiled step, and something like JavaScript, which doesn't have that explicit compiled step? Well, the difference, frankly, is just that with that kind of all collapsed into one step, what ends up happening is that it's a little slower to run because you have to kind of recompile it every time, right? Because normally if you're just kind of, you know, coding in C, you can compile it once and then run it many times after it's been compiled. Whereas with JavaScript and Node, you kind of have to go and recompile it each time. But one of the benefits of that is it can be a little bit more convenient to work with. So it's really just a trade-up between, like, you know, convenience and performance at a very high level. So you'll find that it actually feels a little bit easier to code in JavaScript because you can just run the code all the time. So it's just that standard thing. So let's actually go and run the code we saw before we look at some more examples. So if I've got all this code here, I can just run node and then I can do 1.3 compare to, which is the code we have, right? and then I run it and it outputs 3. It's really that simple. And the print equivalent, if you haven't already seen in JavaScript, is that console.log, because all you are doing is you're actually, it's a weird syntax, but it's really just saying log something to the console, you know? I mean, that's what, when we say print, what we really mean is write to the console. So, you know, console.log kind of makes a lot of sense if you think about it. All right. Next, we're going to go into some more language features. So, a lot of the rest of this lecture, if we kind of skip ahead, is just a whole bunch of JavaScript. I hope we won't take the full time, because I already used some of your extra time on Monday, which I appreciate. So, in JavaScript, we've mentioned already that variables don't have types. Yeah? So there's no ints or doubles or chars necessarily, but what is interesting is that when we create variables in JavaScript, we need to do one of two things, which is either say that this is a constant variable or a non-constant variable. And therefore, before the name of the variable, like you can see here on line 3, we either need to write const, C-O-N-S-T, or let, L-E-T. And if something is let, what it means is that it can be changed. And if something is const, it means it can't be changed. So when I say const years equals 5, what I'm really saying here is that I'm going to let the years variable be equal to 5, and it's not going to change ever, and it can't be changed. Whereas if I said let years equal 5, maybe I could change it to 8 or 10 or something like that. So Bonrick has said, based on the comments, line 3 looks like it's meant to be let, not const. That's kind of true, but just for compiling and linting reasons, which will make more sense later on, it's kind of, the code has to make sense. So I'm going to change that in the example. But yeah, you're right. Like it would normally be let, but that would cause some errors with how things are set up. I'll go through some demos in a sec. If we keep kind of looking here, you'll also see that what's interesting is because we don't have these types, you can kind of very weirdly just start giving random variable names random values. So I can say that, well, name is giraffe, a string, and age is 18, an integer, and height is 2048.11, which is a double, and not exist as undefined, and exist but nothing as null. One thing we will talk about more as we go is in JavaScript is the difference between null and undefined. You're probably familiar with C, where we have like null, which was like a pointer to nothing. We don't really have pointers in JavaScript, so there's nothing particularly, you know, interesting or exciting about that. But there are kind of two ways in JavaScript to define nothing. Not a pointer to nothing, just nothing. And they're both undefined and null. They're both different things, but they kind of mean something similar, but we'll come back to that again later. 9Game says, is it possible to access memory using JavaScript? No, there is no pointer arithmetic in JavaScript, which means you can't access memory directly like you can in C. Now, I can go and define all these variables and then just print them out. You know, and I can easily go and look this up. Variables. Great. You know, so I've got some code here. Years, name, height. I can just console log. I can also just console log strings directly, just like I can in C. So if I run, you know, 1.3 variables, there you go. I get 5, giraffe, 2048.11. You'll see if I change this from const to let, everything still works. It's just I can now change that variable. Here I could say years equals 8, and you'll see that that will change. Right? So now instead of it being 5 here, it's 8. But if I change this to const, if it was const the whole time, NodeJS, the compiler, will actually throw an error and it'll say, hey, you tried to assign a value to a constant variable, and that constant variable was years. So this is one way that, you know, it can be quite useful, because if you make something as const, it's kind of like a guarantee that it's going to stay const, which is, again, very, very useful for help making sure your program behaves. Lachlan says, so it's just like a hash define. I don't know. Like, look, it depends in what way you're asking that question. So is it like a hash define in the sense that you used a hash define for constant variables? Yes. Is it like a hash define in any other way? Probably not. Hash defines are kind of pre-compilation steps. They are constant, but you know, that's also largely just because of how it's set up. You know, they're not actually constant at runtime. So, you know, if you don't think about it too much, yeah, sure, it's similar to hash defines. And yeah, we got all these different types here, and you'll see that they're actually printed out on the terminal as different types as well. So it's really cool about JavaScript. We can just go and declare random things randomly like that. Okay? Strings are where things get more interesting. One of the weird things is that interacting with strings is pretty similar in most programming languages, except C, where interacting with strings is quite specific, because you're dealing with, you know, strings are arrays, strings are pointers, all this kind of shit. But in JavaScript and stuff, it's much simpler. Much simpler, in fact, right? And that simpler nature is that you can just manipulate them like that so easily. So if we look at the code we have up on screen here, we've got, you know, line 2, we're saying let sentence equals my, my. Pretty straightforward. Yeah? I create a variable called sentence, and I let it be my. Easy. Then on line 3, because the sentence is a let variable, I say that sentence is equal to sentence plus name is. So I actually, like I do with numbers, you know how you can say like I equals I plus 1? I can do the exact same thing with strings. It's just that strings aren't numeric. So because strings aren't numeric, it means you can't like add two strings together to get, you know, like numerically, but you can join them together. So when you plus two strings together, you kind of shove them or join them together. And then similarly here, I can say sentence plus equals another string, which will just join it together. Because as you know this already, like I equals I plus 1 is the same as I plus equals 1. And Jacob's asked a good question. Does it matter if there's a single quote or double quote? So no, in JavaScript, you can use single quotes and double quotes interchangeably. Right? And if I just get rid of this bottom code for a second here, and we just try and run this top part, oop, wrong language. You can see here that it says my name is Pikachu because I went and got my, and then I joined plus name is, and then I joined plus Pikachu to it, right? If I look at the bottom stuff here, we're going to learn something slightly different with strings, which is how to print them out, or how to actually, you know, work with more complicated ones when we print it. I can create a constant variable called age that's 7, a constant variable called name that's Hayden, and then a constant variable called phrase, and this is where things get kind of interesting. If I want to create a string that's made up of other variables, there's a few ways I can do it, but the easiest way to do it is to essentially write your string, but everywhere you want to put a variable, you simply put the variable name, you wrap it in braces like this, and you put the dollar out the front. So when I write this within a string, I'm basically saying that, hey, dollar means like I'm going to do something interesting here. Braces are where I put the interesting thing, and then what's inside of that is typically a variable. The one caveat here is this only works when your string uses the backticks, which are typically in the top left of your keyboard, not the single or double quotes. So you can use single quotes or double quotes if you like. They're both totally fine. But you need to use these backticks for strings that are going to have interpolated information inside of it. So if I make this smaller again, and I run this, you'll see that, you know, it says, my name is Pikachu, great. Whereas here it says, hello, my name is Hayden, and I am 7, because it's printing out the string and it's injecting those variables here like that. Now those backticks are critical. Watch what happens when I change those backticks to double apostrophes or single apostrophes, is the output changes. And the output now, instead of saying, hello, my name is Hayden, it says, hello, my name is dollar name, and I am dollar age, right? Very interesting. So those backticks are critical, right? Because without those backticks, then it just prints it out literally, which makes sense. That's how strings should behave. Some interesting questions from people. Someone said, how do we actually print out single and double apostrophe? It's really not too different from C. If I wanted to put a single apostrophe here, like Hayden's, I can just put it in because the string is defined by the double apostrophe, like this. So it just works fine. What happens if I am using a single apostrophe for my string? Well, you can just escape it like you do in C with a backslash. So if you do backslash and then a character, it escapes it, which essentially means, you know, lets you use it. Whereas obviously if you didn't have that, that would be a problem, right? And naturally, if you're in the backticks, you can use either of these because, you know, like the language doesn't care what you use. It's more just like you can't use a single apostrophe if it's also being used to define the start of the string, because that would, you know, that would be a bit of a headache, right? But strings are very, very easy and fun to work with like that. Bam, done. Any other questions about strings before we keep moving on? Just give everyone a second. Yeah, so Anthony says, so not much fiddling with memory like in C. Correct. Yeah, there's far less fiddling, you know, than there is in C. Yeah, there is some good and some bad sides to these high-level languages. Right now, I think you're getting, you know, a strong taste of some of the good parts. But, you know, we'll get to some parts that you might find harder. Yeah, I guess you are Nathan now, Anthony. I think my brain read ANTH and the N I read NATH for some reason. Someone did ask a question before, which was, can you do like I++ and stuff? You can. Like, that's easy to do in JavaScript. You could just do like, you know, age++, but you'd have to make it a let because you're going to modify it. That's totally fine. It's very, the fundamental syntax of JavaScript is actually very similar to C. It kind of feels like, you know, C, easy C, easy, EC. Now if we kind of move on, Sigia asked a good question. What's the difference between let and var? Var's like an older style of let, which I won't go into because the differences are quite subtle. But think of var like let. If you see var on the internet, just read it like let, or it doesn't really matter. Okay, so moving on to some control structures. We again assume you already know what if, else, while, and for loops are. So we don't need to cover how they work, but let's just look at the syntax differences. Here's a piece of code where we define number equals 5, right? Then we say if number's greater than 10, we're going to console log something, else if this, then do nothing, else console log something else. Then we console log a new line. We create a while loop, you know, let I equals 0, while I is less than 5, I plus equals 1. Great, and then we have a for loop at the very bottom, you know, for let I equals 0, I less than 5, I plus plus, like this. What's really cool about this example, in my opinion, is that, and one of the cooler things about teaching JavaScript soon after C, is that if you don't look at the console log part, and you don't look at the let part, and the lack of types, this example is quite literally the same as what you do in C. So there's actually very little I think we need to talk about here. Just kind of works, right? Cool. I mean, I shouldn't just move on preemptively. Like, do you have any questions about this? Like, I just want to ask a few people who are online, because it's very, you know, it is very straightforward if you've already learned C. Yeah, depending on the term you did 1.5.1.1, sometimes they taught for loops, sometimes they didn't. But you're all super, like, smart. And for loops are just condensed while loops. So you look at it, if you haven't seen it before, it is as simple as it looks. Like, wow, a while loop consists of 3 primary components: the setup, the condition, and the increment. For loops are just like that, but syntactically a little bit tighter, right? So, you know, yeah, that's it. Functions in JavaScript, very straightforward. We saw them before. Things don't have types, so therefore we kind of just need this function keyword. Why does this function keyword exist? It's an interesting question, you know. Someone could ask, like a question I've always had, or I've had people ask me, I should say, is that sometimes someone might say, hey, why is like this? Why do we need to write function? Why can't we just like do that? It's a very profound question, because like it's not like there's you know, a law of physics reason that we have to do that, right? That we have to have function here. It's really just about how the language designers design the language. And like a really simple thing is like, if you're a compiler trying to understand a language, if you see that, it might not be immediately obvious to you that this is a function definition depending on how the language is defined, right? This could be a function call. Like if you just look at that in isolation, how do you know that's someone defining the minimum function and not someone calling a minimum function, right? And I think Bondrick summarized it well. Why do we have to put function in front of our functions? Well, because a person who built this made it that way. You know? That you can get into the deeper reasons, but there's nothing like, you know, again, there's nothing like without it, a computer can't, you know, it's just how the language is defined. Languages like Python have similar things with different words. But functions are, again, one of the easier parts of this. Okay, now where things start to get a little bit more interesting is when we get into data structures. And before we get into the actual coding element of data structures, it's a really important time, I think, to take pause and talk about the two main types of data structures that we'll use in JavaScript, which are collections of information. And those two collections that we're going to deal with are sequential collections, basically ordered lists of things, and then associative collections, which are kind of just these random boxes of lots of things mixed together. And we're going to talk about them both. And you've kind of experienced these a little bit, particularly the sequential collections, sorry. So let's chat about them. So sequential collections are essentially bunches of data. They're basically arrays. Hint. But the data in them are referenced by their index. Basically, if you have a sequential collection, arrays, you have data that has a sense of order. And each item, because of that order, has a specific key. It has a specific number that you can use to index it. So if you know this, if you have an array in C, every single item in that array has an index. You can be like, yep, I'm going to get the first element, the second element, the third element, like that. In JavaScript, we also call these structures arrays. But the interesting thing is that the distinction in JavaScript between arrays and linked lists is not a thing. It's just generally not a thing in many high-level languages, but even that's the case here as well. That means that you don't really have to ask yourself questions like, should I use a linked list or should I use an array in my code? Because they're all kind of the same thing. And generally, if you're using JavaScript, a couple things are happening that makes your life easier here. The first one is that because the language is higher level, the performance difference between them is pretty minor. And then also, there's actually quite a lot of things that go on under the hood with languages like JavaScript, which means that you kind of like... it can do lots of optimizations that you're probably not used to. Because if you kind of come from C land, you're used to kind of being like, I need to make the best decisions. But with these high level languages, it can kind of do it for you. Whereas associative containers are a little bit more new to you. And in associative containers, values are referenced by their string key that maps to a value. And the easiest way to kind of explain this is to say that associative containers are most similar, if C is your only language, to a C-style struct, right? And if you have a struct in C, you know this. Your struct does not really have an order. Like if you create a struct in C and that struct, say, you know, like struct student, you know, and you're like, you know, char star ZID, char star name, int wham, right? You know that you can't say something like student 0, right? Or student 1. It doesn't really work like that, you know? The only thing you can do is simply access it by the name of the element inside of it. Student.zid, student.name, student.wham. This is what we call an associative collection or associative container. because, back to the definition, the values inside of an associative collection are referenced by their string key, basically their name, like name, age, and height. And they don't therefore have an inherent sense of order. That's the thing with like structs, right? In a struct, you don't say, does ZID or name or wham come before one another? Now, obviously, you could get technical and be like, well, ZID is probably stored in memory further up than name because it's of how it's stored, but there's no way you can, again, say student 0. So that part's very different. One difference with C is that in C, structs are actually really rigid. With a C-style struct, you have to define all of the names of what's in it at compile time. You can't just kind of add them as the program runs. They're not dynamic like that. Whereas in other languages like JavaScript, they are dynamic and you can adjust them like that, which is very, very powerful, and we'll see some of those examples in a second. Right, I'm just seeing how much we have left. Oh, we don't have a ton left. That's good. Let's actually take a 5-minute break, or maybe like an 8-minute break before we get further into coding. Then we'll kind of go into the actual, like, let's apply sequential and associative containers. But for now, let's take a break and start up. We'll start up again at 6:58 p.m. for those who are watching live. Okay, so we were just talking about sequential and associative collections, right? And the first one we're going to get a bit more practical with is the sequential collections. And in JavaScript, we call these arrays, right? And arrays are mutable ordered structures of the same type. So you get what an array is. It's a list of things, right? But the important thing is that they're mutable, as in they can be changed. You can add stuff to them and you can change them later. And typically, this isn't always strictly enforced, but at least it's philosophically enforced, they should have the same data types in them. In terms of, like, if you have an array of things, they shouldn't be an array of string, number, number, string. No, they should be like string, or like number. And how you actually create arrays in JavaScript is really quite similar to how you create arrays in C. And you can see this here, where in this particular case, I have gone to create an array called names. It is a const array. This is a little bit interesting. We'll come back to what that means in a second. And then I use the same square brackets that I'm used to, and then I add elements to it, and I put a comma between them. Very similar to C. The way we access array items and mutate them is also very similar to C. We can console log, for instance here, the whole array. That's a little bit different. We can console log one element of the array. That's similar. We can modify a particular element of the array. That's also similar. We can push something to the end of the array. That's interesting, and that's new, because in C, when you create an array with 4 elements in it, that array is exactly that size, and it is that size forever. But, well, yeah, until you go and do something to change it. But in JavaScript, you can just kind of say, actually, I want you to add a 5th thing. Add a 5th thing to the end, please. Right? 9Game says, can you push something to the middle? You can. There are functions that allow you to do that. You can do tons of stuff we haven't even begun to talk about yet, right? So you can do tons and tons of stuff, but we'll get to that in a second. Let's actually have a play around with this though, because this is certainly a little bit different. So, oh my eye. When we look at this here, that's like me creating the array. When I console log the array, it will actually print something for me, because JavaScript is smart enough to know that if I say, can you print the array, it will actually just print out the values. And you can kind of see that here. That first line here with the 1 will actually just print out all of the array items with a comma between it. That's kind of how it knows to do things. If you say print the array, it'll print everything with a comma between it. It's quite easy like that. The next line, console log 2, you're obviously just printing one item, and you can see that when I change names 1, which is the second element, Jake, to Jaco, and then I push Rennie to the end, and then I print the whole array again, it now prints out Hayden, Jaco, Nick, Emily, Rennie. Now, this is very cool and very easy to work with, and you can also see this is yet another example of printing a string with the backticks. So I use the backticks here instead of the apostrophes, and that allows me to do something like the $brace, so I can actually print out variables within my string. Super, super, super handy. Really nice and easy. Now, let's keep going, and then we'll keep learning some, just looking ahead. We'll keep learning some more interesting things about arrays. So the next thing is that you can use arrays within loops too, right? And this is kind of how you'd expect. We'd kind of just expect that you can use arrays within loops. And that's the case here if we look at, yeah, there's our arrays within loops. So I can go and create like an array of five items, A, B, C, D, E. Then I can come along and say, well, you know, here's my while loop, you know, console log, and I can console log each element out of the array. Really easy, just like C again. I can do it with a for loop, really, really easy. And I can do it with another for loop here, except instead of needing to use the 5, I can actually do items.length. And this is where things get really interesting in JavaScript. And we're going to touch on this in another couple of slides. Items.length. So items is an array, but where things differ so dramatically is that in C, an array is typically, as you know, just a pointer, right? Just a pointer to the beginning of a piece of memory. Whereas in JavaScript, an array is actually a very complicated object, and you're not going to know a lot of what happens with it, but it's got a lot of interesting information under the hood, and that includes a self-awareness about its own length. So here, items, the array, if you actually do items.length, you will get the number 5. And if you add stuff to it, it increases too. So you don't need to have an awareness externally of what the size of a particular array is. It's all stored within it. So really easy ways to loop through the array. That should all be relatively similar except the items.length part. So really, really intuitive and really, really friendly like that. Cool. Let's actually do something with an array now, something more interesting. This is starting to feel like a bit of a real program here. I've got myself a function called getEvens. That function takes in nums, which is a parameter, which is an array. Very interesting. Nums is an array. It can be anything in JavaScript. It's one of the good and bad parts. But let's come back to what that function does in a second. At the bottom of my code here, I'm creating an array called all numbers, which has, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in it. And then I'm going to console log, I'm going to print what getEvens returns when I pass it all numbers. So I call getEvens with the array and it returns something, and then I print that out. So when I call getEvens with all numbers, this function is called with an array here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what I'm basically going to do here is loop through all the elements, and anytime an element is even, I'm going to push it to a new array. And again, this is where kind of some of the power of these high-level scripting languages comes about, because as I enter this function, I'm going to create a new second array called evens, and it's going to be empty. It's going to be an empty array. Then I'm going to loop through the input array, so I'm going to go through all of the all numbers from 0 to the length of the array, like tick, 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 looping through it. And then for each number, I'm going to check if that particular number is even with the simple, you know, mod 2 equals 0. And if it is even, I will push that number to my evens array. And then at the end of the function, I will simply return that new array. So this is really cool because I basically created an array out of thin air, added stuff to it, and returned it without worrying about any malloc stuff, any free stuff, anything like that. You know, really easy and friendly. Jacob says, assuming we don't know what is inside the function, can nums be either an array or just a variable? So this is the downside. And we'll touch on this more in week 3. This is the downside of this kind of no type approach. It makes it really easy to program, but nothing really stops a compile time you calling getEvens with something weird. It's just the program will simply break, and we can show you that. So if I get this one, 1.3 functions here, and let's run this. In fact, let's change it up. Let's pass in 5 instead of an array. Watch what happens. 1.3 functions. Well, this is interesting. So why did this work? Well, it didn't work, it broke. But Obviously, if I put 4 there, it's not going to work. It's not like it's doing it because it's odd. So 4 gets passed in here. Great. Const evens is an empty array. Great. For loop setup. We let I equal 0. Cool. I is less than nums.length. What is nums.length? That's very odd. Let's try it out. Let's console log it. Let's use the backticks. Nums.length is nums.length. Bit of debugging. There you go. Nums.length is undefined. Okay. So we said before that in JavaScript there are two main ways of saying that this is nothing. And one of them was null and the other one was undefined, right? And in this case it's undefined. And this is one of those weird quirks of the language where what happens is that with nums.length as undefined, like if you try and get like the length of a random number, JavaScript instead of crashing will actually just give you the result undefined. There's some obscure parts of the language. And therefore in this case, what actually happens is that this check here says, okay, I'm going to let I be equal to 0, and then I'm going to check is I less than undefined. We can try that out pretty quick, right? Is 0 less than undefined? False. Is 0 greater than undefined? False. Is 0 equal to undefined? False. Bit weird, but, you know, this is just me playing around with the node interpreter. So this basically this for loop never gets entered when you enter in a number. Therefore we just get an empty array. What happens if we pass in a string? Let's pass in dog. Oops, wrong thing. Same kind of thing. This one's a bit more interesting though, because nums.length in this case is not undefined. It's actually 3, because like in C, a string is actually just an array of characters, you know? And therefore, nums.length is 3, but when we loop through it, each individual nums is in, like, and you can see it here, right? I'll say like, you know, checking nums I, like that. See that? Checking D, O, G. But when you try and get the modulus of D, O, and G, it's never going to give you 0. Like, we could try it out, right? You know, trying, and then we'll put in more debugging code here. What's nums I mod 2? NaN. Whoa! What is that? So then there's another obscure part of JavaScript, which is that, like, JavaScript's a really easy language to code in with some obscure aspects to it. That's the best summary I could give you, right? NaN stands for not a number, and it's the result. It's basically that, again, there was a question that Sigia asked, which is, why wouldn't it just break? It's a good question. Why wouldn't it just break? What did Daniel or someone say above? Because some person just decided that one day. It's just how the language is defined, right? And you can try this again. Watch what happens in JavaScript when I do like 5 divided by 0. I get infinity. You know, what happens when I try and do a divided by 4? I get not a number. You know, 4 divided by 2 is obviously 2. What's dog divided by cat? Not a number. You know, so it's a little bit of a weird thing where basically some other languages would crash or throw an error. In JavaScript, there's a bit more of a tendency for it to give you a result that kind of implies an error. So this isn't inherently bad because, you know, you can just deal with it. But the point is that what you expect might be a little bit different. The program might not crash as often as you think. And then back to a really interesting question that Jacob asked. Jacob said, so as far as debugging is concerned, JavaScript is harder. I don't know if I want to answer that like in a very blunt way because JavaScript's much easier to debug than C. What I would tell you is that because JavaScript is a pretty generous language and it's not typed, there is a tendency for things to maybe seem like they're working when they're not working. More so than what you're used to. Because it's so forgiving. You know? So that's just a subtle kind of thing to deal with. But obviously if we ran this correctly with an array, we would see it work like that. And we would get, you know, nums.length is 10, checking 1, trying 1, 2. So, you know, odd, even, odd, even, odd, even, odd, even. Look, Anthony and Nikhil have asked a question, is there more false confidence in JavaScript? And do we need to test our code more often in JavaScript? And look, no, really, it's fine. This is a very traumatic first example. I think you're getting quite a bias of things here. It's a bit weird sometimes, but it's not like I give any extra thought programming in JavaScript than I do in Python or something else like that. It's not that dramatic at all. So we don't need to worry. It's just something to kind of be aware of and, think about. There'll be a few confusing things and we'll figure those out together. And the last thing on arrays is that because we're working with JavaScript, which is a higher level language, we actually have the ability to do much more clear and concise syntax when doing looping, right? This is cool because from a language point of view, someone kind of just said, you know what? When we deal with arrays and stuff, we seem to be doing very similar things a lot of the time. We tend to just be looping through them. Let's find some easy ways to do that. So you would have seen before, we had some loops like this. While I is less than 5, console log items I. Right? Or if we look at this loop down here, now if I kind of butcher this example for a second, what we're really saying is that JavaScript acknowledges, many languages do this, that there's many times you're going to do this. There's many times you're just going to say that let's start from index 0, let's go to the length, let's print out the element, done. So they came up with a more concise syntax, which was let item of items console.log item. These two things do the exact same thing, right? And I'll put another console log in between just so you can see. A, B, C, D, E, A, B, C, D, E. Really simple. You don't actually need this let here. Typically this will be const because you don't actually change the item. That would be a bit weird. But there you go. So instead of saying, for all this K and index stuff, you can actually just take your array items, say, well, let's loop through it. And each time we loop through it, can you just create a temporary variable called item? And then I will just use that inside my loop. There's a slight variation of this too, which uses, instead of the word of, it actually uses the word in. And in this case, in means don't get me the value each loop, but get me the index. So you'll see that this one will just get you 0, 1, 2, 3, 4, like that. So they're two sides of the same thing. They're just a compact way to loop through an array. In one case to loop through the values, and in another case to loop through the indexes. Now Bill's asked another good question, and Bill's actually pointed out something that I kind of glossed over, I must have forgotten, is that if you haven't already noticed, we don't need to put a \n at the end of a line when we console log it. This is something we needed to do in C, remember? Printf \n. In JavaScript, every console log we deal with has a new line added to the end of it automatically. This is just because people kind of figured out, that you nearly always use it, so let's make it that by default. Jed's also asked, why don't we just directly print console.items? That's a good question, Jed. So you can directly print console.items, but the thing is, when you print console.items, you don't have control over how it's printed. That's it. So if all you need to do is just print it out for debugging reasons, then yeah, just print out the array like that. That's absolutely fine. However, if you need to print stuff out for put it on a new line or display it a certain way, or let's say I wanted to maybe clean this out a bit and say, well, maybe I'll change this one to index, right? And say, well, I'll be like, well, index, or I'll even tidy up at the, index like this equals items index. So basically I'm saying, this is like printing it, right? The yellow bit's the string. I'm saying, well, items, and then what I'm putting in the brackets, the index of where I'm looping to, and then I'm actually going to print out the value at that spot, And now I can get a slightly cleaner looking code, right? Items 0 equals A, items 1 equals B. So most of the benefit of these like loops is just when you want to, you know, format it. But back to the question about the new line, because all of these are adding new lines. What if you don't want console log to add a new line? Google it. JavaScript console log no new line. Right? To answer your questions, if you're running in a browser, then default no, blah, blah, blah. There's a lot to unpack with JavaScript. If you're using Node, then you can use process.standardout.write message. Okay. So if I don't want a new line, then I could say use, instead of console log, I could do, what was it? Process.standardout.write, and then it wouldn't add a new line. Cool. There you go. How hard was that? Quick Google, figured it out pretty quick. You're going to do that many, many times in this course and many, many times in your life, of course. There was another question about this, which was, why is this const and not let? And the rationale behind it is that, well, surely it should be let, because with let, every time we loop, index or item is changing. Therefore, it can't be const, because const implies that it doesn't change. Sort of. How it actually works, if you want to think about it, is like, it's actually like every single time. Like, so if you get your like items array, right? So say we have our array up here of items, like blah, blah, blah. With the for thing, what it's actually going is like, let's go into the first loop, and it's actually creating a whole new variable. And then it's using that variable until the variable's killed. And then on the next loop, it's creating a whole new other variable called items until that's killed. And then on the next loop, it's doing the exact same thing. So each loop, it's actually creating a whole new variable. That's why we have it as const, because in each of those loop iterations, it's like a new variable, and you're not going to change it within that loop iteration. So that's why we do that way. Cool. There were a few questions about, and I will talk about it here, because we're just talking about objects, and then we'll talk about associative collections and stuff, and then we're getting close to the end. Arrays were the JavaScript implementation of trying to solve the sequential collection problem. Objects in JavaScript are the way of trying to solve the associative container problem. And objects are mutable associative structures, like structs, that may consist of many types. So like structs too, if you have an associative collection, or what we call an object in JavaScript, it can be many, many different types, right? You can have strings and ints and everything else. Generally, you use them when you need a collection of items that are identified by like a particular name or string description rather than some kind of numerical index or order. And you can see that here, right? Like we said before, if I have a student, and that student has a name or a score or a rank, well, they're different types, but that's okay. They're not ordered. They don't have none of these come before another. These are all just different types. Like structs too, when we create one of these in JavaScript, and I'll look at this here, I can create it, and then what I can do is I can print out the whole thing. Node 1.3 objects. Like that. I can print out the whole thing. Or I can print out more specifically a property of it through a key. And what we generally say is we say the name is the key, score is the key, rank is the key. This is a key, that's a value. This is a key, that's a value. This is a key, that's a value, like that. And similarly to arrays, I can mutate things. I can change things. I can say that, you know what, student, my object, see like struct, I'm going to change the height in that object from something. But in this case, the height doesn't even exist. And this is crazy. This is where things really differ from C. Because in C, once you define a struct, it stays that way forever. But here, I'm actually going to add a whole new property to it, which is height, which is just going to be the number 159. And now when I run that, you'll see that I print out the whole object, then I print out each of those values at each of those keys, and then I print out the whole object again, which now has a new property, height. Cool. Easy. How fun's that? Super cool. You know, I can go and modify stuff too. Student.name equals Hayden. Anything. Can do lots of stuff. There we go. Any questions about that so far? Quick pause. I'll just wait for people to share their thoughts. Cool. The interesting thing about objects in JavaScript is that you can create them different ways. So one way you could do it is actually just to create an empty object like this. Nothing inside of it. And then you can go and add things to it. And then you can print it out. And this one is like totally fine, right? 1.4 object basic 1. Okay? Name Sally, age 18, height 187. Console.log user data. Easy. Another way you could do it is by populating them like we saw in the other example all at once and then just adding to it later. You know? There's nothing that stops you doing what we did before where we kind of create an object by default like this and then we simply go and add things to it after the fact. That's totally fine too. So it's very, very versatile. Now the interesting thing, and no one's asked this yet, but the const for the object. Normally that throws some people off. They're like, wait. How are you changing age, Hayden? You said it was const, you know? Like, how are you changing that if it's const? It's a little bit tricky to understand, but you can kind of get this if you understand pointers, right? If I create an object user data there, what is happening is that I've created a variable called user data. And this variable essentially references an object over here. And this object contains my key value pair, my key value pair, my key value pair. And we're saying that this is const. And when you say that the variable is const, what you're really saying is that, you know, in the case of these objects, what it references has to be that. So what that means is that user data will always point to this object. But what's in that object can change. Nothing can, we can't stop that. So it's not so much that you can't go user data.age equals 19. It's that you can't say user data equals a new empty object. Then we'll get the error. Because user data always has to refer to the same thing, even if that thing itself can change. Jed has said, how do we change the order of keys? What Jed, I'm pretty sure, is referring to is when we print it out like this. As a general rule, if you want to control the order in which keys are printed, you're probably going to manually start printing things out, right? Rather than, you can't really like ease it. There is no order to it. You know, I don't even know what the specification says. Different languages will say different things about this. Some languages will be like, we just print it out randomly, or the order it was defined, or something. Depends on the language. I don't know what it is for JavaScript. 9game says, what if you do a const variable inside? You can't do a const variable inside, 9games. Basically, like objects like arrays and things like arrays and objects can't, like, they can always just be changed, you know? Anthony has a good analogy. He says it's just like a box. When you say user data is always that box, but it doesn't. User data refers to a box. You can keep adding and changing that box and what's inside of it, but you can't say user data goes to another box. And Jacob says, can you use let for objects? Yeah, I can definitely use let for objects. If I use let here, then I would be able to change user data later on to an empty object, and this code would function totally fine. And then just to reiterate the point home, Allison says, so the variable inside struct can be changed, either it is let or const. Yes. The data inside the box, inside the struct object, can be changed regardless of whether you've defined the object itself as let or const, because let or const refers to what the name points to, not to what's, the underlying properties inside of it. Okay. One slightly obscure thing as well about JavaScript is that you can actually also reference keys of objects a separate way. You can reference it the kind of C-style struct way, right? Where you do like dot, so I say user data dot name equals Sally, or you can actually reference it a bit more of the I don't know how to put it. It's really not much in C, but you can reference it this way, which just does the exact same thing. So if I say node object more2 like this, then it actually has the exact same behavior here. So whether you use the square brackets and then the apostrophes, or whether you just use the dot, both of them work. There are scenarios where the square bracket apostrophe is a little bit more useful, and like I'll give you an example. Like, let's say I wanted to like bulk add or like I'll give you an example. Let's say that I up here say my key is going to be age and my value is going to be 18. Now I'm not going to expand this example too far because we're doing very basic things today. But what's cool about this is that I could come along here and say user data key equals value, like that. So I could actually kind of inject a variable into that key component so that I could like more dynamically construct my structure here. I can't do that with the dot, right? Because if I do like dot key, JavaScript from a language point of view doesn't know whether the dot key, whether the key is meant to be, well, it knows because it defines it, but it doesn't think that that key is like a variable. It thinks that that key is the name. It literally looks for the key called key, you know? And Anthony also says, so variable lookup of an object. Yeah, here's an example. Let me give you an example of where the dynamism is really useful. Say I print out that user data there. Oops. Like this. Where you might use that kind of square syntax we saw is if you say, you know, you wanted to, not this is a bit weird, but let's say you had a list of properties, which was name, age, and height. Like that. And then you loop through it. You say, you know, for const property of properties, because that's the easy way to loop through an array, I could console log user data property, like that, right? So I could like loop through each item in this array and then simply kind of access that particular property of the object, like this. So that's where that square bracket is particularly useful. Generally speaking, I think most people tend to use the dot syntax unless they're doing something dynamic, in which case they'd probably use the square syntax. But they're much of a muchness. You can kind of do either way. However, what I just did, you don't really need to do. See how I did this thing here where I wrote out all the properties? Because JavaScript has some more handy, helpful capabilities, right? Which you can see in our more props file, where if we create a user data object like this with name, age, and height, we can actually use some funny JavaScript syntax to get properties of that object. It's a little bit weird, but if I say object.keys and then I give it my object, it will return me an array of the keys, name, age, and height. And if I ask it for object.values, it will give me an array of the values, Sally 18 and 187. And if I ask it for object.entries of the object, it will give me back an array of little arrays, where each little array is the key and the value, you know? Now, this is all quite useful because now I can come along and I can do this and have a look what each of these three things gives me. Keys gives me an array of the keys as strings. Values gives me an array of the values as whatever type they are. And entries gives me an array of small arrays, which are just the key value pairs. This can be useful, maybe, you know. The point is that there are many different ways here to collect data, you know. Yeah. Good fun. So that's why you don't need the example we showed before, because you can do lots of stuff like this. And this is really useful, you know, if you want to say loop through all the keys or loop through all the values or loop through both. And you can just Google these things. Like, you know, I forget some of them. I always remember object.keys, but I can never remember what these two do again, like off the top of my head sometimes. So if I know it, maybe I'll Google it, or maybe I'll just try it out. You know, it's so easy to try things out. And then the last part of objects here is that you can loop through objects like we do with arrays. It's just that the default behavior of looping through objects, if you just give it the object, is to loop through the keys. So if I do something similar to what I did with arrays, where I say, it actually makes a lot of sense, right? Because if you have an array of 5 items, you know, we go back to our thing here. I got 5 items, A, B, C, D, E. When I do like a for const item of, you know, a for, oh, I deleted it. But let's say you have a for const item in items or something, right? In these particular cases, this is saying that I'm going to loop through each element and you're going to give me the index. Whereas when you loop through a dictionary, you get the key, which actually makes sense because the in syntax for arrays don't give you the value. It gives you kind of the equivalent of the key, which is the index. But for objects, you get the key. And you'll see this here, right? If I have my user data and then I have that for loop there, it'll actually go like through and print that out. And you might think, well, what if I want the values? Well, it's really easy. If you want the values, just go and print out get the user data object and get the value at that key, and you're done. Like, there you go. You know, really, really easy. And then there's another syntax element of objects that can be really useful, which is this one, which is to say, check if name, a particular key, is inside the object. And if it is inside the object, you know, then that particular condition will return true. And you can do something interesting like this. Has name key. If you change this to say height, it'll also say that it has it. Whereas if I change it to you know, blah, it's not going to print out that line because that's not true. So this one is also kind of useful if, say, you have a key that you sometimes add to an object, but you want your code to be able to ask, you know, is that key currently present in the object? Now, one thing we've seen is we created an array and then we console logged the length of that array. And this was a bit weird, you know? Like, a lot of what we talk about is pretty similar to what you've seen before, but this one was a little bit weird. And this touches on something I mentioned before, which is that a lot of what we deal with in JavaScript, particularly arrays and objects, they're really easy examples. Like I said, they're not just in C where they're just data next to each other. They're actually these like boxes with all this other stuff in it that you don't need to worry about, you know? So it's like, if you get your array, it's not just like all the data you have in it, right? Like this. It's also like probably some metadata, like the length of it and a few other things. And in this sense, most things, this is kind of getting to it. Let me just jump ahead. Cool. Okay, let me explain it a bit more detail. So in C, if you have something like an int a, it's just 4 bytes. An integer is just 4 bytes, takes up the space it takes up. If you have something like a struct, it'll only take up 8 bytes. Because in this case, you know, because you have 2 ints and each int's 4 bytes. So these simple types in C were really just basic types that occupied limited memory. And structs were just collections of primitive types wrapped into an object, we called it, you know. And every time we created a copy of a struct with malloc, we would create copies of these objects, right? So if we try and expand this concept into JavaScript, nearly everything in JavaScript is an object. The arrays, numbers, strings, in fact, every kind of thing is. But in JavaScript, it's not just made up of the underlying data, it's often made up of some other properties hidden and some functions as well. And if you're not sure what I'm talking about, this starts to get into the area of object-oriented programming, which we don't really do any of that in this course, but the easiest way you can model it in your head is that in JavaScript, everything is an object, and an object is basically a struct with functions, right? So you know that a struct is just a bunch of data, but an object in JavaScript is like that, but with more functions. And some examples of like what we mean by this, and I'll show you, is that if we go and get ourselves, say, a stock standard array like this, you can actually call some pretty interesting functions on it. Like you can actually say, well, if items.includes A contains the letter A, you can actually do something like that. And that's quite interesting, isn't it? Because again, if you've come from a C background, an array doesn't have, like, we're like calling a function on an object. It's all a little bit weird. So like my advice here is don't think about this stuff too much, because everything in JavaScript's an object, an array, an actual object. Object's such a loaded term because like, an object is just an object, an array is an object technically, and it gets all a bit confusing. But the point is that whether it's an array or an object or an integer or a string, everything in JavaScript is a box. And each box has a bunch of data and a bunch of functions in it. And arrays have this stuff. People have asked before, arrays have a pop. So I can print items.pop. And I'll get an A. Pop's the end. And if I pop it a few times, I get all the different letters. And there's much more than that. You can go look it up. JavaScript array. Just Google this. Array object. And I look and it shows me a whole bunch of stuff like, I can get the value at a particular element. I can concatenate. I can get the entries. I can fill it, filter it, find index, find last, flat map. What was the one we did? Dot includes, dot pop, dot push. There's so much you can do. I could say console log. Let's see if B is in that particular one. Oops. B's not a function. What? What have I done wrong? What do you mean B's not a function? Oh, have I popped too much or something? I don't know. Am I going crazy? Yeah, I think I'm going crazy. Oh, it's a function. Oh, I'm an idiot. Yeah, okay. I don't want to get into that. It's too complicated. Okay. Yeah, let's not do that today. But some other examples might be index of, where index of, for instance, index of is a really old school function, where if I do that, it'll actually look up that particular value and it'll tell me what index it's at. So I could actually, for instance, here say const index equals items.index of B, and then I could say console log items index and print B, like that. So there are lots of these kinds of functions on particular objects that allow us to do cool things. The same is true for strings, right? JavaScript string. It's got a whole bunch of things you can do on it if you scroll down as well. This one's going to be very big. Pad end, there you go. Here's a function, pad end. You give it a number of things you want to pad the end of a string with and what you want to pad it with. So for instance, if I down here have a string that's like, hi Hayden, const, name equals hi Hayden, I could console log name dot pad, was it pad left or something? Pad end with say 20 dots. Well, technically, this doesn't add 20 dots. This pads the end until the whole string is 20 dots. And this is really, really useful because let's say you had a bunch of names. Like you were like names equals, Hayden and Nikhil and Allison, like this. And now I could start saying, well, for const name of names, I would like to console log the name, but I want to pad it out all 20 characters. Why are all our names the same length? That was a bit silly. That was not the example I was looking for. Jacob, say, and Goat. Like, that's not a name, I know. But, now you have something like this. You can actually see that it's very powerful because, it'll actually make sure all the strings are 20 dots and you can... There's so many great, amazing, easy things to do. But this is what I mean about the language will feel bigger, because all this stuff I kind of had to Google, you know? And there's a lot to it. There's crazy amounts of stuff you can do. So you're just not going to feel like you get everything. And that's just a simple side effect of a more powerful language. When you deal with a more powerful language, there's so much more that you don't know. And that's okay, you know? Yeah, Nikhil says it's very expansive. That's definitely the case. So, in JavaScript, can you make your own objects? Yes, you can, but we don't cover that in this course. Most of what you do in JavaScript will be arrays and objects and strings and numbers and basic things. Does this mean that JavaScript is object-oriented? I hear a lot about object-oriented programming, you say. Does this mean I'm programming object-oriented? No, not really. It's a bit of a different thing. I'd say that, you know, you're going to deal with aspects of object-oriented programming naturally in this course, but don't get too caught up on the definitions and stuff. Just, you know, let's write code and make sure it works is the main thing. So the last set of slides, before we get to the feedback at the end, is basically talking about that we can combine these ideas together. In particular, that we can combine our knowledge of arrays and our knowledge of objects together. So what we've done so far is we've just had variables that have either been an object or an array. But here, I'm saying that user data is an array that contains objects. So user data is an array with 2 items, and each item is an object, and each of those items has 3 keys. And each of those keys has a value. So if we go and play around with this now, oh, why is that different? Loop 3. Okay, I started with loop 3 apparently. You can see here that what I can do is if I say get me the keys of user data, right? Like this. Well, user data is an array. So when I call object.keys on that array, they're just going to give me back the 2 keys of the array, which are just the indices, just the indexes. So that's why I get 0 or 1. But if I ask for the entries of the particular array, it's going to give me, you know, 0 and then the value at that point, right? Because it's an array, 2 items, each item's an object. So it's going to try print it all out for me. Now that in itself is not particularly useful. But, you know, you can kind of see what's going on inside of it. Let's say we actually wanted to try and print out everything inside the array. Okay? So what I might do there is I might say, well, user data is an array. So I'm going to loop through user data, you know, dot length with the keys. And then for each item in the array, which remember there's just 2, I'm going to console log for that particular object. Because remember, user data I, and like just for context, I'll show you, right? If I console log user data I here, right? It's just going to print out, oops. It's just going to print out that. It's just that, you know, user data I, object 0, object 1. So when I print out user data I name, I'm going to get the name of the first object. And it says, you know, the person's properties are, and then it goes name, age, and height. And I go name, age, and height like this. And I get this, you know, kind of ugly, kind of useful printout. Sally's properties are name Sally, age 18, height 186. Very tall people. Cool. That kind of we get. But we can make it even more dynamic if we wanted to by simply using what we already know. So we know if we use slightly tighter syntax that we can loop, even though this one's a, oops. Oh, why did I do that? That's weird. I should change this to a, actually let me stay back here for a second. I know that I could clean this up a little bit more by simply going const keys equals object.keys user data I, right? Because user data I is an object. And then here I could say, well, for const key in keys, I could now say console log here, and I could say, well, the key is user data I key. Maybe let me make this a bit bigger. We don't need that much space. And then I could get rid of this down here. Oops. What have I done wrong? So I'm getting the key. Oh, because object.keys user.i. Oh, of keys? My bad. It's really weird, right? Because remember, in gets you the index, and oh, this is like clearly me just getting confused, because like if we actually console log keys, you'll see that keys is actually a bunch of names, right? See that keys is name, age, height, but because I did the in loop and not the of loop, I got 0, 1, 2 because I got the indexes of name, age, and height in their array. Whereas here I'm actually going to, I meant to be of, sorry. It was always meant to be of. Whereas here I'm actually going to get the values out like that. So you can see just by using what we know about object.keys and stuff like that. And in fact, we don't even need to do this object.keys thing, because we learned before that if you simply take an object and you say, you know, const key in that object, it will go loop through the keys anyway. And I get that kind of result. Now, I know some of you are probably sitting there right now kind of, you know, thinking and going like, oh my God, this is really sounds like a lot, you know, and I'm getting really confused about arrays and objects and keys and indexes and ins and ofs and stuff. And yeah, it is like a lot of information, but you'll pick it up. You'll play with it for, an hour, and you'll start to very quickly get a good sense of it. The last example we have here was actually just trying to demonstrate, well, the second last example is that you don't always need to have, you don't always need to have lists of objects. You can also go and have objects of objects. Where's that? So in this case here, I've actually got objects of objects, where my user data is an object with 2 keys, Sally and Bob. Each of those keys itself is an object. So Sally is an object with age 18 and height 186. And then I can just loop through these differently as well. Now, when would you create lists of arrays of objects, or when would you create objects of objects? There's no real straightforward answer. It's really just that, objects are when you want to identify information based on a string, generally. So in this case, it's kind of nice just to say, well, here's Sally's data and here's Bob's data. Arrays are really useful when you want things to have a sense of order. That's one of the main things, right? Fairly straightforward. Yeah, so Anthony's right. Sally and Bob are the keys in this case. Sometimes I get questions from people like, do keys need apostrophes like this? It's optional in JavaScript. They do need the apostrophes if you have funny things in there. Like generally, as long as it's just literal letters, it's okay. But like if Sally has like a funny thing, like a dash, then you do actually need like the apostrophes here. Why is that not working? Oh, wrong one. Then you do need the apostrophes, because if you don't have the apostrophes, JavaScript starts to get really confused. It's just like, is this minus a minus? Like, I don't know if it's a minus or a, just like help me out. So the only time you really need to put the apostrophes there are when you're actually, having funny characters there. So Anthony's asked another good question, which is, so what's the syntax if we want to access Sally's age? Yeah, that's a great question. It really is just a case of saying user data.sally.age. It's that simple. That's how you get Sally's age. Or you could do it the other way. You could say, well, user data Sally age. Like this. Same thing. Get the exact same result. This is the very last example of this lecture. Just before I talk about that, though, the one thing I forgot to mention tonight, just the one thing, is that I want to firstly reiterate that we do have null and undefined as ways of saying nothing. We'll talk about the difference between them more later. In the meantime, the point is you can use one or the other, but just try and use it consistently. So that's point one. Point 2 is that what I haven't talked about is comments. Comments in JavaScript are just the same as C. A double slash for a single line comment, or if you want to do a block comment, it's the /*/ approach. So that's just another quick reminder. So if we do look at this last example here, what's going on here is we are creating 3 students, and each student is an object, and the object contains, keys, name, and score. And then I'm creating an array called students, which is just made up of 3 objects. So now I've got an array of 3 objects, and each object has 2 keys in it. Then I'm going to print out or console log the students. So that should be pretty doable. Which one is it? Where is it? What's it called? 1.3 combining. Yeah. So I can just go and do that, right? Oh my god, no. Wrong file. Yep. There I go. I print out the students, a list, array of 3 objects. Bam, done. But there's a few different ways that I can approach kind of printing it all out. The first one is that, I could say, well, I'm going to go and get the number of students, which is students.length, which will be 3. I'm then going to go and do like for let, and I'm going to loop over those number of students. Each time I loop through it, I'm going to get that particular student. So this is an object. So student here is an object that has a name key and a score key. And then I'm going to check if the student's score is greater than 85. And if the student's score is greater than 85, then I'm going to console log that student's name got an HD. Now, this is a very kind of C-style approach, a very straightforward approach, what you might do. And all the point of this example is to encourage you to say, go and get excited. Go and get excited for the cool things that JavaScript can do, right? Because you can make that all very compact underneath here. You can simply say, well, for student of students, because if you use for of, you are looping through all of the values in a list. So each time you loop now, student is an object. And then you can just simply say student.score is greater than 85. So you can really condense things down if you know how to use the language. That's the last example for tonight. If you have any questions, please post them in the next minute, because we're about to wrap up and let you get back on with your evenings. Bonrick says, can't you just use students I score and students I name? You can, yeah. I mean, there's some elements of like just poor, efficient syntax here and stuff. It's a bit dramatized to make a point. But yeah, no, there's some things that are less to do with the language and more just to do with how the programming's happen. Daniel says, what microphone do I have? It's a cheap-ass microphone from Kogan. It costs like $25. If you Google like Kogan microphone, you'll probably find it. It's okay. It's not high quality. Are there debuggers for JavaScript? Yeah, but we're not going to go into it in too much detail. CGR says, unrelated, but is declaring an array in C essentially just mallocing some space for the array? Yes. 9Game says, first hour of the lecture is a smiley face, last hour of the lecture is a sad face. That makes sense. I mean, the first hour of the lecture, I was kind of telling you what you already knew, just with a different color. Whereas the last hour of the lecture, obviously, we're teaching new stuff. So, don't put too much pressure on yourself. It's just new things to pick up. You'll figure it out. Nathan says, what's happening with next week's Thursday lab since it's a public holiday? Your tutors will talk to you about that. I'll email about Friday. I don't have anything to say right now. We will sort it out. Lachlan says, how do you create a JavaScript file? Do you use gedit? Yeah, you can just use gedit. Literally, like you can just open up VLab and just be like file.js, and you can just write console.log my first file, and then you can save it and close it, and you can just run it node file.js, and you're done. It's really that simple. Super, super, super simple. Is there anything front end in this course? No, there's not. And the last question I'll answer, I'll ask that everything after this point we post on the forum just to wrap up for everyone. But there's so much to unpack tonight. There's so much that we could keep talking about, but The only thing I kind of forgot was the comments, but to be honest, I don't even think I forgot the comments because I remembered when I was explaining it to you that we decided that because the comments are the same as C that we wouldn't talk about it much. But there has been a really good question from Danny because I was touched on in the slides, but I didn't explicitly cover it, which was... Where was it? Where was it? Danny, I've already forgotten. Something about equals. Yeah. Back on these array slides, this one I just kind of forgot to touch on. So it's a bit weird, but in JavaScript, whenever you're doing the kind of double equals things, you always need to do the triple equals. And the reason for this is kind of odd, but basically, if in JavaScript, one of the dumb things, if you check if, like, let's say we have const var equals, or const, name equals 2. And then I say, you know what, let's check if name is equal to 2. And if name is equal to 2, we're going to console log yay. Pretty straightforward idea. Yeah? Yay, name is 2. In JavaScript, a double equals by default actually compares the value, not the type, which is a really annoying language feature. What this means is that's also true, even though one's a char and one's a number. Because if the double equals, what JavaScript tries to do is convert them to the same type and compare them. So if they're the same value but a different type, it's the same. So to get around that, pretty much literally every single time you do a equals, you do a triple equals, because that compares value and type. And that's how we end up, avoiding this scenario where that's not the same, but that is the same. And the same's true for the not equals. Instead of exclamation mark equals, we do exclamation mark equals equals. So just basically always add an extra equals to your equality comparisons. That's all. That's the whole story there. So we're at time. I'm going to end things here. Thank you for coming along. If you have other questions, feel free to post on the forum. See you next Monday. We'll be online next Monday, I think, but we'll make decisions about what we're doing next week on a Friday. But I'm pretty sure we'll be online next Monday, but you'll find out on Friday night. We'll get some feedback. I'm getting feedback from students and figuring it out as we go. So everything's streamed online and recorded anyway, so it doesn't matter. Thanks for coming. It was so lovely to see everyone on Monday. Whoever's listening to this and was there on Monday, I had a great time. So thank you, and have a good evening, and hope you get some sleep tonight.